Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. So first of all, I will give an announcement for our upcoming online training program for the 7 days. This class will be start from the 13th October. Okay. And first 10 people get the 15% discount. Our class start from the 13th October only for the Friday and Saturday in a week. Okay. So if you want to join our online training program, simply contact with this WhatsApp number, also contact with this email. Okay. And all of those information I will keep in the video description. You can easily check and also get the registration about the total 7 days online training program for the beginners. In this online training program, if you are a beginner who don't have any knowledge about the Google Earth Engine or programming, this course is only for you. In this course, I will try to discuss all of those basic programming, then advanced programming, and lot of things for the remote sensing analysis. So I will give all of those things in the video description. You can simply check it and then join, then try to contact with this WhatsApp number and email. Okay, thank you. Okay, so hi and welcome. Can you hear me? Hello.
Yes.
Okay. Okay. Okay, just we are waiting 1 or 2 minutes for joining all of those other participants, then we'll start.
Hello.
Yeah, please.
Sir, previously you have sent some video link and the code related last previous class, sir.
Yeah.
But the link is not in a hyperlink, it is an image only, where I can find out that materials.
Yeah, so basically, okay, just okay, so basically you can get all of those material in our Google Classroom, okay, or the PDF, then slide, and also practice code. And was the recorded video class, you have to log in your YouTube, okay, in your email. Which email you provide me, just simply log in with this email, and I already send you the link about that in our Google Classroom. Okay, you can check the link about the video lecture link. Simply go to this link, then you can easily get the recorded video class. Okay, and before that you must be logging your YouTube with your email address. Otherwise, it not was okay. Basically, it's a privately access only for your own email. Then you can easily access about that. And practice code as a link, you can easily get the as a link. Simply click on this link, then it will be appeared the practice code in your Google Earth Engine code editor. Okay. Okay, so now we'll start today's session. So hope all are well. So basically today is our third number of class, and I hope you all of you already get the recorded video class and also get the practice code, okay, from our Google Classroom. Okay, so let's go to this class. I simply share my screen. So now can you see my screen? Is it visible? Okay, can you see my screen now?
Yes, sir. It is visible, sir. Yes.
Okay, so let's go. Okay. Okay, so hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So today is our third number of class, and basically today I will try to discuss about the some basic concept of the indices, how we can easily calculating the any indices from the satellite images. Okay, it can be NDWI, it can be NDVI, it can be SAVI, it can be EVI, or any types of indices, how we can easily calculate, or any types of raster calculation, different types of band calculation, how we can easily calculate in Google Earth Engine platform. Today I also try to discuss about that. And then we also discuss about the land surface temperature monitoring, how we can easily make the LST map using Landsat imagery as well as also MODIS satellite imagery. And then how we can easily filtering and displaying the satellite images, Sentinel-2. Okay, so previous class I talked about that Landsat imagery. So today's class I discuss about the Sentinel-2 satellite imagery, how we can easily filtering and displaying, and using these satellite images, how I can calculate or monitor the NDWI or normalized difference water index, as well as how we can easily make the time series chart for the NDVI or NDWI, how we can easily create the time series chart in Google Earth Engine platform. I also try to discuss about that, and export any shapefile. Okay, this topic I previous class I already show you that how you can easily export the shapefile or boundary shapefile, and how to add the gradient legend on our map. Okay, and NDWI calculate from the MODIS and Landsat data. We talk about that. So let's go about that. So first of all, I discuss about the filtering and displaying the satellite images, mainly Sentinel-2. How we can easily filtering and displaying the satellite images, and from that how we can easily calculate the normalized difference water index or NDWI map. Okay, so let's go. So basically filtering and visualizing satellite images when you want to do for the Landsat or Sentinel, both of are the same approach. So in this time, mainly first of all you have to filter your specific region. You select a specific region, just import your boundary shapefile, and then simply select your specific region. Suppose in this time I need this Sentinel-2 satellite imagery for the Dhaka city. I choose my region. So I can simply import my boundary shapefile in Asset tab, and then I simply display my boundary shapefile. So this boundary for the Dhaka city, I need the Sentinel-2 satellite imagery, and I also need to filter the image specific metadata or image properties. Suppose this image cannot be more than 1% cloud cover. I need only for this image from the Sentinel-2. Which image cannot be more than 1% cloud cover. I need only for this image. And then we can also filter the any specific time period, or suppose rainy season or dry season or any time period. We can simply a specific time period. Okay. So let's go about that. In this time, I show you that how we can easily filtering the Sentinel images for the dry season or summer season, as well as also wet season or rainy season. Okay, and from that we just calculate about that NDWI, and also show you that how we can what is the difference between the dry season NDWI map as well as also wet season NDWI map. Okay, so let's go. Just I simply open my code editor. So first of all, I have to import it my image collection. So for that, I simply click on here and go to the browse data catalog. Here I find out all of those data set. Then click on the Sentinel. So in here, I can get all of the Sentinel image collection. I want to work with for the Sentinel-2 multispectral instrument, this image collection. And here I can get this type of image collection. So just I simply choose, suppose I want to work for the top of atmospheric. So for now, I can simply copy the Earth Engine snippet from here. and then also work with that. Or if you want, simply search here, suppose Sentinel 2, then it will provide, you can see Sentinel 2 multispectral instrument. We can easily get from here this image collection. So just I simply import that image collection in here. So now this image collection is imported in my code editor, and it's the default variable name as the image collection. It's a variable name, default variable name as the image collection. We can use any name, there is no problem. Suppose I put the name is that, suppose Sentinel 2. Okay. So now I imported my image collection, full image collection, and this image collection is stored in this variable. Okay. So now, first of all, in this time, I just need to filter this image collection for the 2 time period. One is the dry season, another one is that wet season. Okay. So for that, first of all, I need which area I want to need these images. In this time, I need the satellite images for the Dhaka city. Okay. Suppose I simply imported the Dhaka city boundary. Only for the Dhaka city boundary, I import it. And now I give a variable name, suppose ROI. Okay. So now this is my area of interest, Dhaka city boundary, and I also imported my image collection. So now I need to filter this image collection. Okay. So mainly when you want to filter the image collection, first of all, we need to ask a question about the where. Okay. So where it's my region. So I already defined my region is the Dhaka city. And then suppose how. In this time I need only for this image, which image will be not more than 1% cloud cover. So less than 1% cloud cover I need. And suppose when I need the image for the 2 time period, suppose dry and wet, dry and wet season. Okay. So using these 3 questions, I just simply filter my image collection. So let's go. So first of all, I take a variable name. Suppose I put the variable name is the image, suppose dry. Okay. So you can use any variable name. I put the image dry. And then call this full image collection. It's a full image collection is the Sentinel 2. Simply copy and paste here. Okay. So it's a full image collection. It means that this image collection for the whole world. Okay. It's covered the whole world. But in this time I need for the whole world. I need only for the specific region. Where I need a specific region is that Dhaka city. Okay. Dhaka city is stored in this variable ROI. Okay. In this variable ROI is stored my boundary area. Okay, just I simply use the function filter bounds function. Okay, and filter bounds. What is my boundary? My boundary is the Dhaka city, and Dhaka city is stored in ROI. This variable, just use it the ROI. Okay, so now one question is done. Where is done? Then how I filter? I need only for this image, which image will be not more than 1% cloud. Okay, so less than 1% cloud. So mainly it is the image properties. Image properties. So mainly when you filter the image properties, we have to use a function. This function called the filter metadata. Okay. Metadata. So this function filter the image properties. And what is the condition about that? You can see name, then operator and value. Okay. 3 arguments about this function. So what is the name? Name mainly image properties name. So there are a lot of image properties. You can see the image properties. In this time, I choose only for the cloud pixel percentage. I need the less than 1% cloud pixel percentage. Simply copy and then paste in here. It's my name. An operator, set the operator such as less than 1%. Just put here the less than and set the value for 1. Okay. So now my second question is done. How? I need only for those image, which image is the less than 1% cloud pixel. Okay. Then when I need this image. So dry season or wet season. Suppose dry season, just put here the filter date function and put your own dry season time period. Suppose I need the Bangladesh. So just I put here the suppose year of 2020. Suppose 1st January from year of 2020. 04 suppose 30. Okay, just I put my time period on time period. Okay, so in this time, suppose this is my dry season time period. I simply put the dry season time period, look like that. Okay, so now you can see I filter my image collection. So it is a filtering process for filtering. where, how, and when. Okay, so now if you want to check how many images you can get in here, just use the print function and then take image price, simply copy and use the function size function for how many images is available for this, click to the run. So now it displays the result, how many images. We can get the 20 images. And if you want, you can also check about the all of those images acquisition time period. Suppose image, just click to the image drive. So now we can get all of those images acquisition time period also we can get in here. Between this time period, you can see 20 images, and we can get the 20 images acquisition time period in here. You can see. And when you click on here, you can get all of this information about this image. Okay, just simply copy this ID and then work with that. Okay. Okay, can you hear me? Hello. Yeah. Okay, can you hear me?
Yes, very well.
Okay, okay. I think
Yeah.
yeah. Okay, now
The sound,
yeah. So I have a
bad
calling.
connection.
Okay, okay. So because I have
Yeah.
connect with my mobile, so when anyone can call in my mobile, it will be just disconnected. Okay, now it will be okay. Okay, so now okay. Okay, so now we can get all of the single images, just 20 images we can get in here. So in this time, if you want, you can create the, suppose you want to create the median composite, or if you want, you can also work for the single images, no problem. Suppose in this time, I create the median composite. So for that, what can I do? Just I use the median function, use the median, and then finally clip with my boundary. So my boundary is the RY. So now display the image. So use the map dot add layer and call the image bright. Simply copy and paste and click the run. In this time, one layer will be added in here, but I did not see my area. So further, I have to use another function. Just focus the center of the boundary shape file. Use the map dot center object for my object is the boundary shape file RY. Suppose mention the suppose 10, click the run. So in this time we can get the result about this boundary and also focus the boundary in here. Okay, we can get the result to look like that as a black color. Okay, in this time I have to set the visualization about that. So just simply go to the layer 1 properties, click the visualization parameter, and from here just simply set the suppose custom as the 98%, as well as you can also select about the your band, suppose B4, B3, red, green, and blue band. I simply make this combination and set 98% and then apply. So now we can get the true color composite in here. So now it visualizes about the true color composite look like that. Okay. So now this is our image we can get in here. So in this time here you can see I use a function filter metadata. Okay. So instead of the filter metadata function, we can also use the another function. This function called the short function. Okay. Short is another function. So I also show you all of those method. Suppose short, you can use the short function. Short, basically it's also filtering the image specific properties. So just I simply copy the cloud pixel per sentence. In this time, mainly filter metadata function, this function is need when you want to filter a specific range. Suppose in this time, I filtered the specific value less than 1%. Okay, so then I have to use there the filter metadata function. But in this time, when you want to filter this cloud pixel per sentence without any types of range or any types of value, then we have to use the short function. Okay, so simply copy the short and then simply copy the image properties name and paste here. Okay, and then use here the false function. Okay, so in this time, mainly the short function filtering this image collection according to the cloud pixel per sentence and takes the lowest cloud cover images or lowest cloud pixel percentage images. Okay, not any types of 1%, 2%. Which is the lowest? It take all of this image collection. Okay, and if you want, instead of the median function, in this time, what is the median? Mainly median take the middle pixel value of all images and create this composite. Okay, in this time, if you want, you can also use here the mosaic function instead of the median. So it's another function for the mosaic. Okay, it takes all of those images and make this composite. Okay, without any text of the median value or mean value or mix value, it take all of those images and create this composite and make this mosaic. Okay, so in this time you can see I can run the code again. So there's a two new function, short function and mosaic function. Okay, we are also used for the short as well as we can also use at the mosaic. So mainly filter metadata function when you need, when you want to filter the specific range, suppose less than 1%, 2%, 3%, 4%. But when you want to use the short, there is no types of any types of limitation or any types of range. Just filter this image collection according to this cloud pixel percentage. It automatically take all of those lowest cloud pixel percentage images and make it. And what is the mosaic? Mainly mosaic take all of those images. Suppose in this time after filtering here I can get total suppose 20 images. So it takes all of those images and create this composite. Okay, it's a mosaic. But when I use at the median, what happened? It takes only for the middle pixel value and create this composite. Okay, so in this time I show the result about visualization. So click on here. I just choose here the suppose red band, then green band, also blue band, 98%, and then apply. So now we can get the better result in this time. You can see for this region. Get the image for that dry season image. You can see we can get the very clear satellite images for the dry season. Okay, so in this time I can simply import it. Click on here for import it, the visualization. So just click on here. You can see this visualization parameter is imported in my code editor. Just simply copy that from here. Simply copy and paste after the object name. What is my object? This is my object. Okay, after that I have to put the visualization parameter variable. Okay, then I give a layer name. In this time you can see it's showing the layer 1. I put the layer name. It's a dry image or dry season image. You can put any name. Click to the run. In this time, this visualization is set with my map. You can see in this time it automatically showing the two color composite because I use here the variable name in here. Okay, so now I can take this image for the suppose dry season. So in this time I use the same process and I need the image for the rainy season. Okay, so anyone any question you can ask me in here. In this code any question you can ask me.
Sir,
Yeah, please.
These all codes available in notes.
Okay, very slow. Very slow.
These codes are hello.
Yeah, please.
Hello.
Yeah.
These codes available in notes.
Yeah, code link is available. Code link, all of those code link is you can easily access. You can see, go to the classwork and you can get the, you can see material. Suppose you can see first day material, second day's material. So click on here. So here you can get all of those practice code link and also get the YouTube link. Also get the slide link for the all days you can get from here. Suppose second days you can get the all of the second days practice code. Click this link, it will be automatically open this code. Okay, and also show the result about that. You can see the PDF slide and also get the recorded video class. Okay, so all of those skill practice code, all of those material you can get from the Google Classroom. Okay.
You can classroom. Where is classroom?
Yeah. So did you join our Google Classroom? Yeah, I can already available the okay. What is the name? Yeah, Akashpad. Yeah, it's already available. Yeah. You can see already. You can join this Google Classroom in here. Okay. So from this you can get all of those information, all of those material, all of those assignment you can easily access from here. Okay, and also do that. Okay. So you can get all of these things from here, Google Classroom. And you already joined this Google Classroom. There is no problem. Okay. Okay, so any question in here? Yeah, please.
Sir, I have confusion about mosaic function.
Yeah.
Uh, in mosaicing, what we getting as a output is a all band, or there is a somewhat sum or median, or what means in
Okay.
median we only getting the median value of that
Middle
pixel, huh?
pixel value, yeah.
But
Got the median, yeah.
in mosaicing, which band value we are getting?
So in this time, you can see the mosaic, mainly it composite all the images in a collection using the marks function. Okay, so it marks all of those image collection and create this composite all the images. So in this time, here I can get suppose 20 images or 30 images. So all of those images in a one collection, composite in a one collection using the marks function. But when I use here the median, it created the middle pixel value and make this composite. Suppose in this time all of those images, in this time this image, it's create the all of those images, composite all the images in a collection. In this time, suppose in my collection 20 images I can get in here. So it composite all the 20 images.
Suppose one image
Yeah.
for having 6 bands, okay,
Yeah.
and we are getting 20 images. So this our mosaicing will have 20 into 6 bands in one image.
Yeah. Yes. Yes.
All 120 bands we are having in this collection,
Yeah,
no?
all of those band consider.
Okay. But in case of median, we are getting only 6 bands for one image. As a output, only 6 band will be there.
No. It's talk about the pixel value, middle pixel value. Suppose this image has a middle pixel value, okay, or median means the middle pixel value. All of those, suppose that all of those images, it takes the middle pixel value and create this composite, okay.
Okay.
Or when you use the mid, so it takes the all of those images and we can get all of those band. There is no problem. You can see when I use the mosaic, I can get all of those band. When I use here the median, then I also get the all of those band. Okay, so basically it's created the middle pixel value and create the median composite, and mosaic it create all of those images, make a one using the marks. Okay, create the composite all of those images using the marks. Yes, please. Yeah, please. Any question, please?
Sir, mosaic means
Yeah.
there is two methods, sir.
Yeah.
See here, suppose side by side two images are there.
Yeah.
They will connect the two images. That is called mosaic.
Okay.
But
In this
here
time,
you
all
are
of those
telling that
images,
in
all
this
of those
time-
images connect
1
in
minute,
here.
sir. 1 minute.
Yeah.
Yes. 1 minute, sir. Suppose in this 10 layers are there. Suppose I'm telling that 10 images are there. 1, 2, 3, and so on 10. So each pixel is here 10 layers is equal.
Yes.
So suppose I will take one pixel, it will be column 10 pixels are there. In column wise, it is 10 pixels are there. So 10 pixels means you are taking one, and you are taking, suppose numbering you are given 10 pixels. That average it is a here value, or how the value will be taken, sir? Mosaic.
Okay. So in this time, it suppose in this time you can see without mosaic, what the result I can get in here. I show the result first. In this time, okay, just click the run. Suppose I print that image collection, you can see here. You can get the 48 images. Okay. And when I use at the mosaic, then it create the composite. So I just simply show the layer, at the map.add layer, and click the run. You can see. So all of these images in this time, suppose 48 images, connect and create the full image collection. Create the composite from all of those images. Total 48. Okay. It create the full image, create the full composite from here. Okay, so it mainly it's not any types of medial pixel value or mean pixel value. It creates, suppose all of those images just join or connect each other and create this type of composite, total 48 images. And from here, when I use the clip function, just it clipping our boundary shape file. Okay, so you can see here they're already make about the mosaic. So it composite all the images in a collection using max function. Okay, using max, they composite all of those images in a collection.
Sir, excuse
Yeah.
me. I think we have there are two types of mosaic.
Yeah.
The first one mosaic, it means if we have the image not cover all area we decide, he select another image. This is the main mosaic. But
Yeah.
another one, it speak about the quality band.
Yes.
Okay, here he select from the best band and take the mean or medium.
Okay, quality
Value.
quality mosaic is also available. We can
Yeah,
see the quality mosaic is also
Quality
available.
mosaic,
Yeah.
it's mean, yeah.
Yeah.
But mosaic, if the area we decide ROI, the image not complete, he look another image. This is my understanding, but
Yeah.
I don't know. He must be have or take the mosaic and make the composite image.
Okay, so basically
This is
this,
my understanding.
yeah,
Is
yeah,
it
okay,
correct or
understand.
not?
Yeah,
This is
yeah,
my
okay, I understand about that. Okay. So just you remember that a mosaic mainly takes all of those images and make a one collection using max, and then create this type of composite. Okay, and here include all of those band is available. All of those band is available, but it create the composite from all of those images. Total 48. Not they are taking their middle pixel value or average pixel value or standard pixel value. Just create this composite using all of those images in a collection using max. Okay, so now you can get that if you want. Yeah.
Sir, can you mean in console? Can you show how many bands this image dry is having in console by printing all the bands?
Yeah, it has all of those band is available. Just you can simply print that. Suppose I simply use here the print function. Suppose print and image dry. Simply copy this, and now we can get all of those band. It created the only for the one image. You can see after mosaic, one image and has total 16 bands is available. All of those band is available. Okay. It provide all of those band. Okay, but when you apply the media, we can also get the same number of band. There is no change in the band number. It just simply when I take the median, then it create the middle pixel level and create this composite. When I use the mosaic, it create the composite from all of those images. Okay, so in this time we can get all of those images and all of those band is available. And when I mosaic, then it will be just a single image. Okay, and this single image created from the total 48 image collection using the mosaic. And now it display the image look like that. Okay. Okay. So now in this
sir, one more question.
Yeah, please.
So what is the qualitative difference between these two images? One we are getting from mosaic and one we are getting from median function.
Okay, there is a node any type. Basically, it's the visualization. Okay, sometimes we need the median, sometimes we need the mosaic, sometimes we need the mean. Okay, there is a not any types of difference, but when you use the median, we can get the middle pixel value. In this time mosaic, it create all of those images and make a one composite. Okay, suppose when you use the mean, it create the mean average pixel value and create this composite. Okay. But there is no in types of but just our main target is that we can get the clear satellite images anyhow. Sometimes some region is the work for the mosaic work better, some region is the median is work better. Okay, so it's depend on your region. Okay, sometimes you can apply the mosaic, but you can see this your region is not showing the perfect image. We did not get the proper satellite images. But when you use the median, then we can get the better image. Okay, so basically it's depend on your visualization. But your main target is that anyhow how we can easily get the proper satellite images. and work with that. Okay. Okay. So now in this time I just show the result for the suppose another for the wait season. Just simply copy the same code from here and then paste in here. Just I change the variable name. Okay. Suppose I put the variable name in this time image for wait, and just simply change the date. Suppose 06. Suppose October. Okay. And mosaic same thing I use in here. Then simply copy this and paste here, and then give a variable name. Suppose wait image. Click to the run. In this time another layer is also come. In this time we can get the rainy season image. You can see. So mainly rainy season we can get a lot of cloud in this satellite images for the rainy season. So you can get the two layer. You can see one is the wet image or wet season image, another is the dry season image. So mainly you can see the wet season image. There are a lot of cloud we can get in here, but this type of cloud we can remove from the Google Earth Engine platform using the Landsat Sentinel. Both of images, how we can easily remove the cloud. Okay, so this topic I will try to discuss in the next class about that, how we can remove the cloud. You can see you can get, but dry season you can see very clear image. There is no any types of cloud or haze. We can get the very clear image for this. Okay, but wet season we can find out the some cloud. Okay, but this type of cloud we can easily remove using the cloud mask band. Okay, cloud mask band we can use and then remove this type of cloud and get the very clear satellite images. Okay, so I can see we can get the two types of images in here. So one is the dry season, another is the wet season. So now using the both of images, I just calculate the normalized difference water index or NDWI. So mainly identify the water body. So NDWI mainly used for identify the water body on the surface. Suppose in this time, I want to show the result for the Dhaka city. What is the condition for the water surface for the dry season as well as also wet season for the water body. Okay. So for that, I use the NDWI technique or normalized difference water index technique. Okay, apply the two images, wet season image and dry season image. Then I can easily get the result and also display about the water body for the two time period. Okay, so let's go how we can easily apply the NWI. So there are a lot of way for calculating this type of equation, NWI, NDVI or EVI. There's a lot of process. I will show you all of those step one by one. So first of all, you have to know about the formula for the NDWI formula. What is the formula about the NWI? NWI formula is that mainly green band minus near infrared band divided by green band plus near infrared band. Okay, so this is the formula about the NWI. So now this formula, I just need to apply both of images, dry season image and wet season image. Then I can get the NWI map and display the water body for the two time period, dry season image and wet season image. Okay, so let's go how we can easily apply this formula. So there's a lot of way for use this type of formula in Google Earth Engine platform. First of all, I show you the very easiest way. Okay, for very easiest way is that I simply suppose is the first step. Easiest way is that we have to use a function. This function called the normalized. So this is a function. Normalized difference. It's a function. It's called the built-in function. When I apply this function and mention here the band name, it automatically calculated this type of equation. Okay. So in this time, I simply copy this function and then open it the docs tab. Then we can get the all of those things you can see. Normalized. Okay, normalized difference, we can see this is the function. So computes the normalized difference between two band. Okay, so in this time, any two band, not only for green and near infrared band, any two band. Suppose NDVI have a two band, NWI has a two band. So any two band, when you want to make the normalized difference function, you can just simply use here the normalized difference function. This function you have to use. And the normalized difference is computed as first band minus second band divided by first plus second band. Okay, so when I mention here the first band and second band, it automatically calculated first minus second divided by first plus second. Okay, and this is our function, normalized difference function. So in this time I just apply this function and then calculated the NWI, both season, dry season and wet season. So for that, what can I do? Just take a variable. Suppose NDWI for dry. Okay, NDWI for dry, and I need to call the dry season image. Okay, you can see here I already create this is the wet season image. I already create about that, and another thing is the dry season. Just I simply call the dry season image. So just simply copy this variable because this variable is stored at the dry season image. Copy and then paste. Okay, after that use the function, this function called normalized difference. Just write here the normalized difference. So this is my function. So in this function I have to mention first and second band. Okay, first band in this time we can see the formula is the green, second band is the near infrared. Okay, just put here the green band is the B3 and near infrared is the B8 for sentinel. Okay, so now it calculated the NWI for the dry season. You can simply copy the same code, copy and paste here, and now I want to calculate it for the wet season. Just simply call the wet season image. So the wet season image variable, this variable is stored at the wet season image. Just simply copy the variable name and then paste here. Okay, so now it also calculated for the NWI for the wet season. So now let's go display the result for the NWI map. So for that, what can I do? Just take a variable, just use a function map dot add layer and call the NWI dry. Simply copy and paste here. Okay, and make a visualization parameter. So for that, I simply put here the mean -1 max up to +1 and put here the plated function and make the plated such as I simply put the color plated. Suppose I am to show the color plated as a red, then use here the suppose yellow, then use here that green, then use here suppose blue color. Okay, for the water body. So just I use here this type of color. After that, put a layer name. Suppose I put the layer name, it's a NWI for dry. Okay, now do for the same things for the simply copy and paste here. I simply change it. Suppose this variable name NWI wet season. You can use any variable name. Then simply copy this variable name and paste here. Okay, now give a layer name. Suppose NWI wet. So now click to the run. In this time it's showing the result. You can see in this time, you can see in this time we did not see the result. We did not see the proper result of the visualization because in this time I put the range -1 to +1. NDWI value will be -1 to +1 all time between this range. But for my region, what is the minimum pixel value of NWI and what is the maximum pixel value of NWI? I don't know. Okay, so that's why I randomly put here the -1 and +1. But when you download this map and open this map in ArcMap software, then you can get the exact value. What is the accurate value for the minimum and maximum NWI value? We can get in here. Suppose you can see here, I simply open my previous map and show you that. So you can see. Suppose you can see this is the one kind of map. This value is not -1 and +1 is not. So for this region, for this Dhaka city region, we can get the 0.5 is the highest pixel value and -0.6 is the lowest pixel value. But in this time when I put the visualization in here, you can see -1 and +1 then I did not get the proper result. Okay, this range will be -1 to +1. It will be okay. There is no problem. But for my region of interest in Dhaka city, what is the minimum NWI? I don't know. So how I can get the value? So this value, there is a lot of way for getting this type of minimum pixel value of NWI. What is the maximum pixel of NWI? There's a lot of way. But easiest way is that you can simply click on here. Suppose just click on here. And then suppose stress 98%. So now it automatically showing the minimum and maximum value of NWI for this dry season map. You can see we can get the -0.5 to 0.1. We can get the result for and this result for the dry season NWI. Okay, as well as you can see the wet season. Simply click on here and stress it. Now it will display the result. What is the maximum and minimum NDWI value for this? You can see we can get the 0.3. Okay, for this wet season NDWI, you can get the 0.3, 0.5 to 0.3. Okay, just in this time I simply change the value for getting the better result. Suppose I put here the value such as the 0.5. Also put here the suppose 0.5. Now we can get the proper result about the suppose put here the 0.5. So 0.5. Okay, now click to the in this time you can see now water body it will be visualized. We can get the water body as a blue color. Loaded. Okay, so in this time, this type of blue color identify about the water pixel value. Okay. So you can see here, this is the wet season. First layer is the wet season, and it's the dry season. Okay, it's the dry season. It is the dry season water body, and it is the wet season water body. Okay, we can get the rainy season or wet season. We can get the lot of water pixel value. You can see. Okay, so in this time, you want to just calculate it. How much water body we can got for this rainy season? Okay, how much water body will be increasing for the rainy season? Okay, so this type of do in here. Suppose in this time I want to calculate how much pixel of water body in the rainy season we can got in here. In the rainy season, how much water body can get in here? So for that we have to use the thresholding technique. We have to apply and then just show the water body for the rainy season water body. Okay, so in this time you can see the result for that is that it's a summer season. Okay, and it's the rainy season water body pixel value. So in this time I want to calculate it how much area in the water body in the rainy season. Okay, for calculating in this time we are applying here the thresholding technique. Suppose thresholding mainly it's selecting the specific pixel range. Okay, so now how it will work you can see. So in this time this variable is stored at the dry season NWI map. This variable is stored at the wet season NWI map. Okay, so now we just talk about the thresholding technique, and using the thresholding I just extract only for the water body in the rainy season. Okay, so for that take a variable. Suppose I put the variable name is that wet season, suppose water. You can put any variable name. So in this time I just put the equation such as in NWI simply copy. Suppose NWI wet, this pixel value greater than, in this time I put here this greater than 0.2. Pixel value is greater than 0.2, and also put here the another thing is that and when this NWI dry season less than In this time, you can see NWI. So mainly, if you want to check the value, suppose I click on here. Suppose I click on this in this time. I click on here. So in this time, I can get the value about this pixel value. NWI, you can get the NWI. You can see in this time NWI weight. Okay, you can see NWI weight season is the 0.3. This pixel value is the 0.3. But you can see here, it's the less than. Okay, less than means that 0.4 negative pixel. So negative pixel means that there is the no water body. Okay, in the dry season. In the dry season, there is the no water body because I can get here the negative pixel value. And mainly negative pixel value in NWI, it means that there is the no water body. Okay, and when I can get the positive or high positive value, it's identify about the water. So using this, suppose randomly I take the point and I choose about that. Mainly NWI water greater than 0.2, and when I can get the less than, so it means that it's a rainy season water. Okay, you can see the rainy season I can get the 0.3, but dry season I can get the negative pixel value. It means that there is a no water. So I check the another. Suppose I click on here and then check the pixel value about that two season. So here I can get the, you can see 0.29 and I get here the 0.09. Okay, so mainly permanent water body. Permanent water body mainly dry season. So dry season permanent water body is the less than 0.2 all time. Less than 0.2 all time. Okay, and rainy season water body all time greater than 0.2. Okay, all time 0.2 greater than. So for that, using this, considering this pixel ratio or pixel value, I just simply take the NWI rainy season water. Rainy season water will be greater than 0.2 and NWI dry season less than 0.2. Consider all of those pixel value will be rainy season water. Okay. So now I just simply put this thresholding value in here. So now I want to just simply marks. Okay, just marks water marks. So for that, take a variable. Suppose I put the variable name is that water max, and then simply call this variable name wet season water and paste here, and then simply with the function update max function, update max, then call this wet season water equal 1. So in this time, I just show the only for the one means that I show only for the water body. Okay, just one feature. So just use the equal to 1, and then I want to show the result. So for showing this result, just take a variable map dot add layer and call the water max, and then from here I simply set the plated. I show the water body as a blue color. It will be double T. Okay, PA double T. Okay, and after that, okay, use the quotation, and then I simply put this. It's a rainy season water body. Okay. The curly bracket. Okay, so you can, and then mention about the colors. So now click to the run. You can see in this time it's showing only for this water body in the rainy season. Okay, I take the question after that. Just a minute. In this time it's showing only for the water body in rainy season. You can see. You can see. So this type of region of water we can find out in the rainy season. Okay. Water body, and this all of this pixel value will be greater than 0.2. Okay, so anyone in question, you can ask me. Yeah, any question? Okay, so anyone
Yeah,
any
please.
question?
Yeah, please. We need to extract the water body between range,
Yes.
maybe from 0 to 2.
Yeah, any range, any range. You can put any range. There is no any types of limitation for which pixel. You can put any range. Okay. Suppose in this time I put my range. Suppose greater than 0.2 and less than 0.2 from the dry season. But you can put any types of range or any types of thresholding and extract the information. Okay. So in this time I randomly put the example. But using this approach, you can take any types of pixel value and get this. There is no problem. Okay. Yes, please.
Yeah, sir, here equation in formula, you are written equation 1. What it is?
It's not an equation. It's just it's a thresholding technique. Okay, thresholding mainly it's take the specific range of pixel value and marks with that. Okay, so it's not any types of equation. In this time, it just take the pixel value. Suppose from here it take the greater than 0.2 and also from here it take the less than 0.2. Okay, and
Okay, sir, that
and
is
marks
the
about that.
yes.
Yeah, it's just a thresholding. So using this technique we can suppose using the thresholding technique we can extract only for the vegetation. With using the thresholding technique we can extract only for the land. So there's a lot of information or lot of feature we can easily extract. Use the different types of thresholding pixel value range. Using the different types of thresholding pixel value range we can extract a lot of feature from the surface or remote sensing technique.
No, no, that logic is okay, sir, but
Yeah.
can you go for once code?
Yeah.
This one logic is okay, sir.
Yeah.
NDMail underscore wet dot gt greater than 0.2 dot and NDWI dry less than 0.2. So that that condition pixels will be filtered. But
Yes.
after that, you are applying water mask. Water mask, how it will be updated mask means it is in a pre-functions.
Okay. So basically, you can see here using this thresholding, I generate a new image. I want to generate a new pixel value, and this pixel value I need to update using the max function. Okay. So this
Okay.
result, when you want to display, you have to must use here the update max function. Okay. So for that,
You
you
are
can
creating a mask. You are
yeah.
creating mask.
Yeah.
So that mask is a water mask you are creating
Yes.
using your previous condition.
Yes. Suppose using this condition, I just simply update marks
Okay.
this condition. Okay, and store it in this here. Then I can get only for
Why?
the water body pixel value.
Yes, yes. But why in this condition, can you go for down, sir, that code? But why in this case, suppose wet underscore season underscore water is enough. Why dot equation in bracket one you have written, sir? Is it
Which one?
required, sir?
Which one?
This water mask, sir. Water and mask. Yeah, that one only, sir. Highlighted.
Yeah. So watermarks. Okay. So after that, you can simply this is thresholding. So this thresholding we have to in this time you can see. Okay. So just without that, I show the result first. Suppose I simply show the result. Okay, then click to the
Why
run.
we put
You can check the result in this time. You can get the what type of result you can get in here. You can see. First this layer. Okay, it will be open. Okay, you can see in this time what type of result you can get. Okay. It's totally showing as a blue color because I use the blue color range in here. Okay, without update maxing. Okay, so in this time we are just use here the update max function. Just extract the water body only water body from here, and set equal to 1. Equal 1 means that it have only for the one feature I want to display for water. So just use at the equal 1. So basically you can see in the
Sorry,
map.add layer, we
what is the
just set
meaning
only for the
of
one feature, which is water. And this come from this wet season water according to this condition. Okay? So that's why in this time we have to use at this
Sir,
water mark.
that is clear, sir. But here my question is, uh, dot equation underscore bracket one. It is not necessary, sir. Is it necessary, sir?
Yeah, this equation, yeah, it's it.
Dot equation bracket one. That wet underscore season underscore water is required because of we are using that function
Yeah,
previously.
and it's only for the one.
That
Okay. So it's not a mandatory. Okay, it's not a mandatory. You have to use the equal to 1.
it's not,
Okay, it's not a
it is
mandatory. If
not
you
a
want to remove that, we can get the same result. There is no problem because
yes, sir.
it's only showing only for the water body or one class. Okay, so that's why it's not a mandatory to use that. But in this time I use that the equal to 1. There is no problem about that. And if you don't use the equal 1, it's also not problem. Okay, because it's only for the one class of water feature. Okay, so there is no problem about that. Okay, so now we can get the result look like that for extract only for the water body pixel value in the rainy season. So now I want to calculate it how much area is available for this water body, mainly watermarks area. How much area is available for that, for calculating the area. So for calculating the area, we have used a lot of way. So in this time, we are just show you the smallest, easiest way. Mainly, it's called the image.pixel area. Because in this time, I calculate the pixel area, how much pixel is available for, you can see. Okay, so in this time, from this map, so this is the water body map of rainy season. So now from here, I just calculated how much area is available. Okay, using this function called dot image dot pixel area. You can see the function. So this function you have to use. Okay, so mainly this function calculated the pixel area in square meter unit. Okay, it calculated the function unit is the square meters. Okay, so now I just use this function and calculated that. So for that, first of all, take a variable name. Suppose I put the variable name is that area water. You can put any variable name, and I simply call this watermarks. Simply copy and paste here, and then just use the function multiply function. This function multiply with art engine image dot pixel area. Okay, this function. Okay, so after that, just use a function reduce region function. Okay, reduce region and put all of this argument one by one. So make a curly bracket start and also curly bracket in here. First of all, reducer. So in this time I calculated the total area of water body. Okay, use at the dot reducer dot sum. So it's calculated the total area. And geometry is that it's the boundary shape file variable name. In this time RY. Scale is a resolution for 10 meter. And then I assume it's not 10, I assume remove that. So now I just simply print that result. Then we can get the result, how much total area. Unit will be a square meter. Just simply print area water, simply copy and then click to run. It's calculating the result. Okay. So now you can get the result look like that, you can see. And this unit is the square meter. So just we can simply convert the unit in the hectare or a square kilometer. So for that, for conversion, take a variable, suppose area, and it's a number. You can see it is a number. It's a number. So that's why in this time we have to use a function at engine dot number. Okay, because it's a number. And this number is stored in a variable, area water. Simply copy and paste. Okay. And in this time, this number I get from ND. Okay. So just use a function, get from ND. Okay. After that, I simply suppose hectare. Just simply multiply with 1 into 10 inverse 4. So use our 1 E inverse 4. So now we can get the result in hectare units. Just simply print that area. Click the run. Yes, please. Okay, any
So
question?
what is that multiply 1e power
Okay,
minus
so
4?
just you can see the result. What is the conversion for the square meter to hectare unit? Okay, when you want to just multiply this value with square meter, any result, it convert into hectare automatically. Okay, so you can also prove that. So square meter to hectare, what is the formula or what is the law? You can simply put that. Okay, in this time, this is my square meter result. Okay, this is my square meter result. Okay, when I just multiply with this value, it means that 1 into 10 inverse 4. Just multiply with that, it calculate in the hectare. Okay, in this time we can get the result 1725 hectare. Okay, just is a formula about the square meter to hectare. Just put this, multiply with this value, it will be calculated in hectare unit. Square meter to hectare, we can convert. Just simply multiply with this value.
If I need to convert to kilometers or meters.
So for the kilometer, we can just simply multiply 1. In this time, we have, for the kilometer, we have to divide. So use that the divide. 1 is 6.
From where can I get unit for conversion?
So unit is basically we are using the square kilometer or hectare. Both of unit is okay. There is no problem. You can see we can get this result. Okay, 17 square kilometer. Okay, and for the hectare, just simply multiply 1e inverse 4.
If I need meal,
Yes. So now we can get the result in hectare unit. 1725 hectare. Okay.
I mean, excuse me, I need from where can find conversion from unit to another.
This one mainly we are just
Multiply or divide 1e 4 6 like this. From where can find this in Google?
it's a scientific notation about that number. Suppose 1 into 10 to the power 6 or suppose 1 into 10 to the power 6 or 1 into 10 inverse 4. So it's type of scientific notation. We use that the 1 inverse 4. So you can simply check
Okay.
it. What is the meaning about the 1 inverse 4? You can see. So it's just 0.001. It's called the 1 inverse 4 or 1 divided by 10,000 as a fraction. Okay. So it is a scientific notation about that 1 inverse 4 or 1 is 6. Okay, so now I can get the result in here. So this is the process. And finally, if you want, you can also make the time switch chart about that. Okay, for the NWI, what is the condition about the different time? We can also check it using the time series chart from here. So before that, we also discussed about the another thing is that for the time series chart, we can create the two types of time series chart in Google Earth Engine platform. One time series chart come from the ready-made dataset. Another is the unready-made dataset. Okay. So now what is the ready-made dataset? So basically you can see the Modis. It provides a lot of product, ready-made product. You can see a lot of ready-made product, LST, lot of ready-made product we can easily get from here and make this time series chart. Suppose in this time I work with for this time series chart for that total land surface temperature emissivity is 8-day global 100 kilometer resolution. I want to use this and then make the time series chart. It's a ready-made data set. Okay. And why it's called the ready-made? Because this data set has already available for the band. LST day 1 kilometer band is already available. So which data set give you all provide automatically the different types of band, NDVI band or NWI band. So it's called the ready-made data set. Okay. Suppose that the another data set. Suppose I simply search here. Suppose Landsat NDVI. Okay. We can get a lot of ready-made data sequence. Landsat 8-day NDVI, 32-day NDVI, annual NDVI, 32-day NDVI. Suppose like when I click on here, I can get the totally ready-made data set. You can see here I can find out the ready-made data set because they are already created the NDVI band in this data set. Already create the NDVI band. Okay. So in this time I did not apply any types of formula for creating the NDVI. I can just use the band and make the map and also make the time series chart. Okay. So it's called the ready-made data set. And with the unready-made data set, suppose in this time I create the NWI from the satellite images. Okay. So it is the unready-made data set. Okay. For that, I have to apply the roster calculation or band calculation. Just apply this type of equation. Then create the NWI. Okay. So it's the unready-made data set. Okay. So ready-made and unready-made, both of data set, how we can easily create the time series chart, I will discuss in this time. So let's go. Okay. So in this time, first of all, this data set, I show you that how we can easily create the time series chart. For creating this time series chart, I open a new code editor. Just open a new code editor. And then copy this image collection from here. Just copy and then paste in my code editor and give a variable name. Suppose I put the variable name is that Modis LST. Okay, you can put any variable name. So this is my image collection is imported. And from this image collection, I have to choose the specific band. I need to select the specific band. So use add the function, select function. And select the specific band is that you can see it's provide the band LST day 1 kilometer. And what is the unit? Kelvin. Okay. Just I simply paste in here. So I simply choose the image collection. And from this image collection, select the specific band. So now from here, just simply put the specific time period, any time period. Suppose I put the time period such as filter date and put the time period year of 2020, 1st January from year of 2020, December 31. Just put this time period. Okay, so now this is my image collection. Just I simply show how many images in here, print and Modis LSP, use that the size function, click to the run. So now it's provide how many images? 46 images. So in this time, for the 1 year, I can got total 46 images because every image interval is the 8-day. You can see the 8-day. If the interval is the 8-day. Okay. So that's why I can get the for the 1 year, I can get the 46. You can see the 46 multiply with 8, almost 1 year. Okay, 368, almost 1 year. So every 8-day intervals. So that's why I got total 46 images in a 1 year. So in this time, when I make this time series chart using the 46 images, here I get total 46 data. Okay, 46 data in here. When I use the 1 year time series chart, I can get the 46 data or 46 point. When I make the chart, I can get the 46 point and 46 value for 1 year. Okay, and this is my image collection. And it's a 8-day interval, so that's why for the 1 year we can get the 46 images. And this is my image collection, 46. So now I just create the time series chart for any region. You can put any region. So in this time you can see mainly time series chart. When you want to do, just we have to use a function UI dot chart dot image dot series. So in this time you can see what is the argument about that. First argument is the image collection. You must need the image collection. So we already created the image collection 46. And second argument is the region. What is your boundary? You want to make the time series chart for which you where is your boundary? You need a specific boundary. Then reducer. In this time you calculated the maximum LST or minimum or average LST. Which one you need? It is a reducer. Reducer mainly calculated the maximum, minimum and average pixel value. So in this time it calculated the maximum LST, minimum LST or average LST. Which one you need? Just simply put that. Scale is the resolution of your satellite imagery. In this time, what is the resolution? You can check 1000 meter or 1 kilometer. You can say 1000 meter resolution. So an X property is the default system time start. Okay. So in this time, I just choose my area of interest. You can put any area of interest. Suppose I choose the area of interest is the Dhaka city. Just put here the Dhaka city in here. Just simply put in here Dhaka city. So in this time here you can see it will be imported and default variable name is the table. You can put any name. I put the name such as the ROI. You can put any name, no problem. So in this time, my image collection is ready, 46. My region is also ready, ROI. Reducer, I want to calculate suppose average. Scale is ready, X property is ready. So all of those argument is now ready. So now I can easily apply and make the chart. Okay, so let's go. Just I make a curly bracket start and also curly bracket int. So for that, first of all, image collection. How many images? In this time total, 46 images. It is stored in a variable. What is the variable name? Modis LST. Simply copy and paste here. Then region. What is your area of interest? Dhaka city. And where the Dhaka city is stored? Dhaka city is stored in ROI. And then reducer. You want to calculate what's the what do you want to calculate? Maximum LST, minimum LST, or average LST. I want to calculate the average LST. So use that the EE dot reducer dot mean average scale. What is the resolution? 1 kilometer, 1000 meter. Okay. X property. What is the X property? X property is that system time study default. Okay, there is no. You can all time use the system study. So this is my all of those things. I just need a variable, take a variable chart and store in here. In this time, when I just print that, suppose print. So now it create the time series chart for Dhaka city. So just click to run. So now I can see the result. Okay, we can get the result look like that, but this result has some problem. This problem is that you can see it's showing the 15,000. It's showing that 15,000, or you can see the 15,000. So in this time, this result is showing look like that because it has a problem. But this is the process for making the chart. Problem is my data. So what is the problem in this time I face in this data? This problem is that this data has a scale. You can see has a scale. Okay. So when I use the data for the local region, such as Dhaka city, Bangladesh, or any specific region, done for the whole world. For whole world, this minimum and maximum value is the okay. There is no problem. But when I want to use this data set for my specific region, then we have to use the scale value. Otherwise, I did not get the proper result or accurate result. So previous class, I discussed about the Modis NDVI. And in this Modis NDVI, we also discussed about that how we can easily reprojected the scale value, okay, for the modis NDVI, so that I can get the result -1 to +1. Just we have to multiply 0.001 for the modis NDVI. In this same approach, we can also in this data set, then we can get the proper LST map. Okay. In this time, otherwise you can see it showing that look like the data. You can see 15,000. Okay. In this time, it's not reprojected. This data is not scaled. In this time, I need to reprojected this scale value. Then I can get the proper result. Otherwise, it's showing that this type of result we can get in here. Okay. So now, this is the process. Mainly, this is the process for the time series chart. Okay, it's the okay. There is no problem. Using this process, you can easily apply for any data set. Suppose in this time you apply this data set for that another. Suppose I show the another, suppose LST for NDVI. Suppose I have to create the 8-day NDVI time series chart. What can I do? Just apply the same approach. Take a new code editor. Same approach. Okay, and how I can reproject the scale value of the LST, I'll show you the later. Just a minute. So before that, we try to show the another example. Suppose modis Landsat NDVI. So in this time, I want to use the data set and make the time series chart. Just simply copy, and then paste, and give a variable name. Suppose put the variable name is that L. You can put suppose L8 NDVI. You can put any name, no problem. After that, you have to use the select function. Okay, select. Just select the band name. In this time, you can see they are already created the band NDVI, and there is the no scale. Okay, so that's why this data set is the already reprojected. Mainly, we have to use the scale only for the modis product. Otherwise, Landsat, ready-made data set, or then Sentinel ready-made data set, we don't need to use any types of scale. It's already reprojected the scale value. Okay, I simply copy the NDVI and paste, and then put the specific time period. Suppose I put this time period, use here the filter date function, and put here the date 2020 1st January from 2020 1st December 31. So this is my time period. So using this time period, I just show the result. So I want to display the result. How many data set I can get in here? You can see print. Simply copy and use the size function. So now click to the run. In this time, we can get this number 46. Same. Okay. So why I get the same? Because it's also 8-day. You can see 8-day global. Sorry. Okay, it's tier 1, 8-day. Oh, it's a 8-day. Okay. So not 18, it's a 8-day. Okay, modis NDVI composite for 8-day. So that's why in this time we can get the 46 image collection. Okay, because 46 into 8, we can get almost 1 year. So for the 1 year, 8 days interval, we can get total 46 image collection. So this is my image collection. So now I just use this function UI.chart.image.series. Just use this function. My image collection is ready. I need the region. What is my region? Region is my boundary shape file. Suppose I need the Dhaka city NDVI map. So just put here the asset and import the Dhaka city. Okay. So now I put the name such as the RY. Suppose RY. And then give a curly bracket start and curly bracket end. First of all, image collection. Image collection, how many images? 46. And 46 images stored in variable LST and DVI. Region. Region is that our boundary. Boundary is that ROI. Reducer, I have to calculate the average NDVI. E dot reducer dot mean. Scale is the resolution for 30 meter Landsat. Okay, then X property is that system time start. So now all of those things stored in variable chart, and now just simply print. Click to the run. So now it's generating the chart, you can see. And in this time you can see we can get the reprojected result. So you can see you can get the 0.25. Okay, so now this result is the okay. There is no problem. Okay, click on here. I can download the data in a Excel file. So just click on here. It will open a Excel file. You can download the data Excel file and download the PNG file from it. So in this time, mainly this is the process for creating the ready-made data set. Okay, suppose there's a lot of ready-made data set available in Google Earth Engine platform. All of those ready-made data set, just apply the same approach for creating the time series chart. Okay, so now anyone any question about the time series chart, you can ask me. Any question in here for creating the time series chart for the ready-made data set? Yes, please.
Sir, we are getting this for a single pixel or as a, on an average for an image.
In this time, it create this time series chart for the whole region, for the Dhaka city whole region.
Sir, there are several pixels and having several values altogether. So
It
this
create
is
the
for
mean result.
okay, okay, okay.
You can see the mean mean. Okay, so any question? Okay, so I think it's okay. There is no problem. So using this approach, in this time, using this approach, you can create any types of time series chart from the ready-made data set.
Sir, what is the incidence of this chart? What we are getting? Suppose we are applying mean. So whole season, suppose it is starting in January.
Yes.
Okay, 9th January. Okay.
Yeah.
So at 9th January, the value is 0.161.
Yes.
So whole region is having NDVI of 0.161 as a representative.
Yes, for the whole region average result.
Okay.
But when I use at the max, then it's showing the whole region maximum result. Okay.
So it is sufficient to represent a large region with a single value for a date?
In this time, this data set, it's basically this, it will be work for this date. Okay, this 46 image has a specific time period. You can check the time period. Suppose just simply print, then we can get all of this time period about this data set. And this time interval is that 8 day. Let's create this time series chart according to this data set. You can see. You can see the first 9th, 17, 25, 22. Okay, so every 8 days create we can get this images for single images. So in this time you can see this is the single image. Okay, so it's create from this image. Suppose this is the single image, so this single image created the average result and make this time series chart. For this single image it create the average result and make this time series chart. For this single image it create the average result and make this time series chart. Okay, and finally we can get the result look like that from this total 46 images of NDVI. Okay, so any question?
Yeah. The modis, how can reproject or
What?
scale?
Yeah. Scale mainly lens scale is a 30 meter. Okay, so any question?
Yeah. Here, I ask about the modis data.
Okay, more is that I discuss later. So in this time, any question in the time series chart or everything is okay for that. Okay. So now we talk about the modis. Okay. So basically in this time, our chart is the okay. There is the no problem, but we face the problem in our data set. So in this time, this data set, I need to reproject it. Then I can get the proper result. This basically they are already provide the scale about the data set 0.02. So this is the scale about the data set you can see. So using this scale, we have to apply and then make the result. So you can see 0.02, as well as it's showing the unit is the Kelvin, so that we can easily convert the in the degree Celsius result. Okay, so now in this time both of things we can do, just simply reprojected the scale value as well as also convert the unit from